We're going through exercise 10C, and in this video I'll be answering question 20, which says, in how many ways can a group of 6 people be divided into 2 equal groups? Well, if I have 6 people and I want to divide them into 2 equal groups, obviously it's going to have to be 3 people in each group. So to represent that mathematically, what we're going to do is say, well, I'm choosing from 6 people, and then I need to put them into groups of 3. So it's going to be 6 to 3. Now you might want to put in that other group, but it's actually not necessary. So if you were to put in that other group, you'd be timesing it by, well, if 3 people are going into this group, there's going to be 3 people that I can choose from for my second group, remembering that 3 people are now in the other group, and I'm trying to put them into groups of 3 as well. Now, if I found what this equaled, so I come over here and I go menu, probability, combinations, 6 and 3, and then I times that by menu, probability, combinations, 3 and 3, it's going to equal 20. It's going to equal 20. Now, the reason why it's going to equal 20 is because this right here, that's going to equal 20, and this is going to equal 1, remembering that when my n and r values are the same, it's simply going to equal 1. So I really didn't need this second step here. I could have simply gone, if I have 6 people and I'm trying to put them into groups of 3, what am I going to get? Because implicitly in that, it's kind of like there's 3 more people left over to be put into groups of 3. And there's only one way, if you have 3 people, to put them into groups of 3. Everyone's just going into that one group of 3. So we don't have to worry about that. So that is my first answer. Let's now go on to B, where I have 2 unequal groups if there must be at least one person in each group. So let's list out the ways I could have that. So if there are 6 people I'm dealing with and I'm trying to put them into 2 unequal groups, well, I could have 1 and 5. I could have 2 and 4. I couldn't have 3 and 3. That I couldn't have because they're equal groups. Now, would I have 4 and 2? And would I have 5 and 1? Now, hopefully you can realize that because I'm dealing with combinations, the orders don't matter. So 1 and 5 is the same as 5 and 1, and 2 and 4 is the same as 4 and 2. But let's just leave them up for the time being, realizing that we actually don't need to calculate what these are, but let's just leave them there for the time being. So if I'm going to have this one, how would I mathematically show this? Well, I have 6 people before me, and I'm trying to put them into groups of 1, and then I have 5 people left over. So that would mean that I have 5 people left over and I'm trying to put them into groups of 5. So that's what I'm left with. Remembering that this 1 here means that there's already 1 person in one group, so I've got 5 people left over. And once again, we're in the same position as we were up here. The fact that I have 6 and 1, I know that that equals 6, and I know that 5 and 5, well, I know whenever my n and r are of the same value, it's going to equal 1. So therefore, my answer to this is going to be 6. Now, I actually didn't have to do that. I could have just simply gone 6 and 1, and then implicitly that's already there. We kind of already know it. But if you still want to write it out, you could. Now, let's keep on moving. Actually, before we keep on moving, now that we've done this, 1 and 5, let me show you that that is the same as 5 and 1. So let me prove that to you now. So let me get my red pen back. So if instead of doing it this way, by going, I have 6 people and I'm putting them into one group, and then timesing that by I have 5 people and I'm putting them into groups of 5, what if instead we say I have 6 people and I'm putting them into groups of 5, and then I'm going to times that by, well, if I have 5 people in a group already, that means I have 1 left over, and I'm putting that person into a group of 1, obviously. Well, 6 to the 5, that's the same as 6. And this 1, 1, well, that's just the same as 1. So I'm going to be left with 6 as my answer here. And let me just keep the consistency. I did that in blue, so let me do this in blue as well. So that is how you would approach that question. And as you can see, I got the same answer both times, 6 and 6. But obviously, you don't have to count that one as twice. because we're dealing with combinations, the order doesn't matter. So in a sense, you could eliminate this one. We don't really have to look at it. You could have just as easily crossed out that one, but I'm just going to cross out this one. We don't have to look at it because that would be repeating ourselves. Let's now move on to our next one, in which we have 2 plus 4. So the way that we're going to approach this is that we're going to say, well, I have 6 people that I'm choosing from, and I'm putting them into groups of 2. And then if I wanted to, I could say now times that by, well, if there's 2 people in my first group, that means I have 4 people left to choose from, and I'm going to have to put them into groups of 4. Now, as you can see again, 4 and 4, that's going to give me an answer of 1. So now I simply need to figure out what 6 and 2 is. So if I was to come over here and do that and that, I have 6 people and I'm putting them into groups of 2, should be 15. And there it is. It's going to be 15. Then 15 times 1 is simply 15. So 15 will be my answer. Now, let me do that. And let me just, for completeness sake, show you that we would have gotten the same answer is if we did it for over here. So 2 and 4 and 4 and 2, they're going to give me the same result. And we can see that because if I had 6 and 4 and I times that by 4, if I have 4 people in this group, that means I have 2 people left over, and I'm putting them into groups of 2. So sorry about that. So this means I have 4 people in that group. So I have 6 people I'm choosing from, and I'm putting them into groups of 4. So that means I have 4 people in one group. That means I have 2 people left over, and I'm putting them into groups of 2. So as you can see, I've got that. I know that 6 and 4, that's going to be equal to 15. And then 2 and 2, that's going to be equal to 1. So I'm left with 15 again. So as you can see, both ways gave me the same answer, but obviously you would not count them twice because we're dealing with combinations where the order does not matter. So let me get rid of that. So that means now when we're solving this, what we're going to do is simply add together 6 and 15, which will give me an answer of 21. So your answer will be 21 for this. Now, before we finish up this exercise, let's again reflect on the fact that this and this is giving me the same answer. And specifically, it's 6C2 and 6C4 are both giving me the same answer as 15. And this is actually what we saw in the very second question of this exercise, in which it asked us to compare your answers for parts A and B. Here we had 5 and 3, and here we had 5 and 2. And as you can see, if we were to put this in the factorial form, you're going to be cancelling out the same thing on your numerator and denominator and actually getting the same answer. So that is why this works. So that's the reason why we could do it in any order that we like. So hopefully that makes sense and explains what's going on in this question. Hopefully this was helpful to you in answering question 20 from exercise 10C.